Vignesh.
Vignesh from also Zhongshan University, and he'll be talking about galactic environments, FRB hosts from number count analysis.
Yeah.
Please welcome Vignesh.
Ah, I think it's working.
The laser works, but I guess.
Ah, okay. What?
How did it work for you?
Ah. Okay. Sure. Thank you. So, thank you for this opportunity first. So, I'm Vignesh from National Zhongshan University, Taiwan. I'm going to talk about an interesting approach to study the galactic environments around fast radio bursts using galaxy number density. So, this is an first time we are going to try this type of technique in FRB science. So, before going on into the my topic, I'll give a quick introduction about like what are FRBs. Even though two previous speakers gave a good introduction about FRBs, I'll just quickly wrap up this. So as they said, FRBs are like millisecond emissions, bright radio emissions that is happening all across the sky. We are like expecting more than 1000 FRBs per day that is coming from various different sources. So most of the sources are like extragalactic origin, so they have like a long distance. So typically these FRBs have an energy scale are up to 10 power from 10 power 35 to 10 power 42 ergs per second per hertz. So why should we study them? So FRBs, like uh, these are some of the important questions, open questions in the field of astrophysics, as we know, like Bisnick baryon problem or Hubble tension or weak equivalence principle. So we believe that using FRBs we could answer all these questions. So if you're really interested to pursue FRB science, and if you're really interested how can we apply them to modern problems in the field of astrophysics and cosmology, I suggest you to listen to this particular talk where my colleague uses FRB to study the Hubble constant, to constrain some good results on the Hubble constant. Okay. So basically depending upon sorry so basically depending upon the nature of FRBs, there are two types. One is repeaters and one are non-repeaters. So as the name suggests, so if you receive FRB signals from same source like more than one time, so we consider that as repeating FRBs. One classic example is the one which previous speaker mentioned, the hyperactive repeater. So basically we received around 12,000 FRBs from the same source itself. Another thing is the non-repeaters, where we receive only one type of, I mean like just only one emission from the same source. So why should we study these population and what significant it has? So basically if you see that we FRB people believe that this repeaters and non-repeaters might have different progenitor mechanism. As previous speaker suggested that the progenitor mechanism of FRB is still an open question. We don't have any conclusive way that this is the correct progenitor mechanism for FRB. So for example, if you see that there is a lot of theory which suggests that magnetas sorry okay. So magnetas could be the emission mechanism for repeating FRBs, whereas like supernovas and other catastrophic events could be the source for non-repeating FRBs. So to really investigate, we need to localize the FRB and we need to study its host galaxy, and thereby we can find its progenitor mechanism. However, there is a problem. So this is typically an artistic way of representing the Chines observation field of view. So basically it's like we have a large error circle in the sky, and it's difficult to pinpoint the source where it's exactly coming from. Let's say here we can see like there are more galaxies here, and it's difficult to pinpoint the origin of the FRB source. So my method overcomes this localization problem, as we focus here on large scale galactic environments around FRBs. As you can see that instead of like pinpointing exactly from where the FRB is coming from, we just focus on the large scale galactic. environment. So basically we take 6 megaparsec radius around the FRB source, and we try to count how much number of galaxies that is present within this aperture radius. So using this we can overcome this localization problem. Thereby we improve the sample size by 1 order of magnitude. So here typically we use 240 FRB sources, I mean like non-repeater sources from CHIME collaboration, and 27 repeater sources from CHIME collaboration as well. So for the galaxy data we use WISE PS1 catalog. So my motivation of this particular work is that I need to understand, or I need to figure out whether FRBs, both repeater and non-repeater population, live in same or different galactic environment. So by doing this we can constrain their progenitor. So here are my sample selection criteria for this particular analysis. So I am not going into detail. Let's see. So basically I said we use aperture radius. To set the aperture radius, we need to make sure that if we take an aperture of, let's say, 6 or 7 megaparsec, the FRB should be within this aperture radius. So for that we plotted the positional uncertainty of both in RA and DEC as well, and tried to figure out the optimal aperture radius. We found out that mostly about like 90% of FRBs are well within the 6 megaparsec radius. So basically the idea from this is that if we take 6 megaparsec radius as the aperture size, we can almost have all the FRBs are well within this aperture size. So how I am going to do is that basically I will take an aperture and try to count number of galaxies within this aperture, and I repeat the same process for about 100,000 times. So, and after doing this I normalize it with the I normalize this density values that I have found and create this histogram. So basically this is an example. This is not like my final figure. This is basically an example in which this particular FRB is located at a very high dense galactic environment. So I do the same for all the FRBs that I have, and after doing that we use KS test to figure out whether the repeating population and the non-repeating population are similar or different. So here the blue color curve corresponds to the non-repeating population, and the red color curve corresponds to the repeating population as well. So from this figure we found out that there is no significant difference between the number density or galactic environment around the FRBs, which is a crucial result. So to conclude my slides, the major question that I am trying to answer here is like, do the repeaters and non-repeaters live in same galactic environment or different galactic environment? So from the data which we used and from the results which we found that there is no significant difference between them. However, this opens up an important step here. So as we suggest that since there is no difference between the galactic environments around them, there could be two possible conclusions here. Either these two mechanisms, I mean like these two populations, both repeaters and non-repeaters, might have same galactic, I mean same progenitors, or all, since both the populations are taken from same CHIME catalog, and some papers suggest that this repeating FRB and non-repeating FRB are typically same. I mean like there is no difference between non-repeating and repeating FRBs in CHIME catalog, which means that if we observe non-repeating FRBs for a quite long time, we can expect that they tend to repeat. So this is my conclusion. So this is still an ongoing research, and as far as this particular result, we are preparing a paper, so stay tuned for the paper. So in future what is the possible direction is that we are going to compare this with pre-existing models, like many theories suggest that this supernovae could be an mechanism for emission of FRBs or long GRB or any other progenitor scenarios. So we are going to compare this galaxy number density around FRB and compare this with the progenitor mechanisms to find out which could be the optimal mechanism for producing FRBs. So thank you.
Questions for Vignesh?
Well, thank you for a nice talk. Outside the field here,
Yeah.
just wondering, you've compared the overdensities between FRBs.
Mhm.
I was wondering if you find any association of these overdensities with large-scale structures or galaxy types.
Actually, thanks for the question. So there is one particular paper, I think it's Dressler, so which suggests that this over density, number density could be there is a established relationship between number density as well as the galaxy types. So we can use that. In this work, I didn't do that. In future, I'm trying to do this also. Like we are going to find whether this high dense environment and low dense environment could really, from this we can extract the galaxy type information from using the established relation.
The results show below average, right? If you
Ah,
look at the histogram.
here?
Before that,
Ah, this one.
normalized density, the average seems to be below 1.
Hmm. Uh, um,
Oh, we can talk later.
yeah, sure. I'm not sure. Thank you. Any other questions?
What about the number of FRBs in the field, like that you use? Did you use
Here.
the entire child data? Or
Yeah. So basically, in this plot, we only have one source. So I take in such a way that this is constructed only for one single FRB, keeping it as center.
okay, and you do this for
All
all
the,
the
yeah, yeah, yeah,
okay,
all the 247 non-repeaters and 26 repeaters as well.
okay, that's good.
There's one.
Thanks for the call. I was wondering, it seems you use the 6 megaparsec as your aperture. Then did you control the distance of the line of sight, like the redshift?
Yeah. So I think here we are talking about the. I didn't take the foreground galaxies or line of sight. I just take a snap. It's more of a snapshot. It's more of a snapshot at this particular redshift. So basically, what I do is like this FRB has. We can derive redshift using some mechanism like Mechat relation or stuff. So using that, I created an FRB slice, which means it's more of a snapshot around this particular FRB.
So it's just 2D projection.
Yeah, exactly,
Yeah.
2D projection.
I see.
Any other questions? We can have a few more, I suppose. I can have one. Oh, here. So, no, first.
Same picture. So the red line is the experiment. Sorry, the observation data.
Yeah, yeah. So
And
this red line is like this around this particular FRB. So basically, what I do is I construct random circles and try to count the number of galaxies inside this. So that is using that I created this histogram, and this red color line corresponds to the number of galaxies within the 6 megaparsec radius around FRB. So basically, this red color curve is translated to a line here. The density inside this red color circle is converted to this line.
so this is the new method to analyze the location,
Sorry.
the location of the FRB, right?
No, actually, it's more like we are trying to find out the environment in which the FRB is located. We know the location from chime data itself. So it's more like using that we are trying to find out how much over dense or under dense or what kind of galactic environment is surrounded by the surrounded within the FRB.
Any more questions? you're comparing non-repeaters and repeaters distribution, but have you compared just to random fields?
You mean the random versus FRB?
Yeah.
Actually, it's working. It's on ongoing progress.
Okay. Well,
Yeah.
this helps you understand bias.
Yeah. Actually, that's a good point. We are doing that. I think we can expect soon.